said something very important. You know that there's something called an electric circuit. Electric circuit. How does an electric circuit work? Like I said before, I said we have something called a key. We have something called a key, a device called a key, which is also part of, which is very much important. Now, in the aspect of key, I said that a key can either be open or closed. So you think that a key can either be opened or closed. Now, if a key is opened, current will not flow. Current will not what? Flow. Will not flow. But when the key is closed, current will flow. So you can have the key open, you can have the key closed. So when the key is closed, current will flow. But when you have the key open, current will not flow. So it means that the key can also act as a switch. The key can also act as a switch. Now, what's an electric circuit? An electric circuit is the arrangement. Say that an electric circuit is the arrangement. That means this arrangement consists of the source of electricity. The electric circuit consists of the battery, which is the source of electricity. It consists of the bulb, which is the load. And also consists of a conductor, which is the wire that you use to connect it. So it consists of the battery, consists of the bulb, consists of the load, which is the electric bulb, and also consists of the switch, because if you don't have a switch, you will not be able to switch on and off the what? The electric circuit. So take note that the electric circuit consists of the battery, consists of the bulb, consists of the conductor, which is the wire, and also consists of the what? The switch, which can either turn it on or off. So an open circuit, again, like I said, an open circuit, you have current will not flow. But in a closed circuit, current will what? Flow. In an open circuit, current will not flow, but in a closed circuit, current will what? Flow. In this aspect. Now, apart from this, I also talk about potential difference of voltage. Potential difference. Now, in the aspect of potential difference of voltage, I will say that in the aspect of potential difference, PD, or voltage. Now, voltage is the potential difference. You can call it the potential difference between 2 points in an electric field. So we can say this is the potential difference. We can call it the potential difference between 2 points in an electric field. Between 2 points in an electric field. So the potential difference is the difference between 2 points in an electric field. And this potential difference now, PD, we can call it EMF, we can call it voltage, and the unit is volts. So I said PD is electromotive force, where this E you are seeing here stands for electromotive force. EMF is now EMF. Now, how do we define EMF, or how do we define voltage? How do we define EMF, or how do we define voltage? We say the EMF, electromotive force, is the work done per unit positive charge. Is the work done per unit positive charge involved in moving. Is the work done per unit positive charge involved in moving a circuit. Is the work done per unit positive charge involved in moving a circuit, or the total energy per coulomb obtained from a cell or battery. So we can say it's the work done per unit positive charge. Just take note that EMF is work done per unit positive charge. So V is equal to W over Q, because we know that W now, if you cross multiply, will give you QV. So we have already gotten two formulas now. The first formula, we said Q is equal to IT. Remember, we said Q is equal to IT. Then we said current is the charge per unit time, or the rate of flow of what? Electric charge. Now we also said that EMF, electromotive force, is the work done per unit what? Positive what? Charge. That's work is equal to KQ or QV. Work is equal to QV. We've been able to get this out now and be able to understand it very well. So this is another aspect that you also need to take note of. and so W is equal to QV. W is equal to QV.